All right, I'm back here with another example question for our hypothesis test for standard deviation. And here's our question. It says, consumers may be interested in whether the cost of a particular calculator varies from store to store. Based on surveying 50 stores, which yield a sample mean of 73 and a sample standard deviation of 14, test the claim that the standard deviation is less than 16 at the 0.1 level of significance. And you can see here on the left-hand side, we have some things we're trying to get. So I'm going to try to take a snip here of, I guess I'll just keep it short here, and we'll kind of run through this stuff. So our claim here has to do with this here. It says test the claim that the standard deviation is less than 16 at the 0.1 level of significance. So 16 squared is something. That's going to be the value that goes here. Our null hypothesis is that it's going to be equal to it. Let me just copy and paste this here. Okay. We surveyed 50 stores, that's N. Yield a sample mean of 73 and a sample standard deviation of 14. And then sigma comes from the claim here. It's 16. And alpha equals 0.1. So that sigma squared is what I'm going to need to fill out this thing here. And since I don't know my 16 squareds, yeah, I was going to be way off here. So this is 256. Now test the claim that the standard deviation is less than, so we'll do less than, and then we do that sigma squared. Our degrees of freedom, remember, they're one less than our sample size. So this is 49. And then we need to figure out our test statistic. So again, the degrees of freedom in this case is equal to n minus 1. And that's 49. Now we have our null hypothesis and that there. Let's figure out what our test statistic is. And I have that formula over here. This is our chi-squared test statistic. So it's really the degrees of freedom times s squared, and it's divided by sigma squared, which we happen to have here, or we can do this and square it there. Excel usually follows the order of operations, but just in case, okay, yeah, we're good. Again, if we're entering those, we usually round them to 2 decimal places for the test statistic, and then the p-value we round to 4 decimal places. So I've been harping about drawing a picture here, so let's draw a picture of our deal here. Now we were less than, so we are left-tailed. So if I have my test statistic here, and I don't know where 37.52 makes it in this, but we're getting the area to the left of it. Remember, we have 0 here as the start for our chi-squared distribution. I know a sloppy picture there, but the p-value is going to be the area to the left, so I'll do a chi-squared distribution function, put in my test statistic. Notice I'm going to use the unrounded one, the degrees of freedom. And then if I want the area up to there, I use true. Now, just want to see if we needed to round that a little better. So I just made it larger, 1157. Looks like it will work for the p-value. So the test statistic p-value, I can't remember what it was, 1157. And then we make a comparison. Our p-value happens to be greater than alpha. The test statistic leads us to, remember, we reject if our p-value is less than, so we fail to reject. These other ones we never really use. Those are there to trick you. Now, if we keep going here, as such, the final conclusion is that we failed to reject, so there is not sufficient evidence to conclude the standard deviation in calculator price is, and here we finish with the alternate hypothesis. So less than, and what was from the claim, 16, I think, right here, test the claim that the standard deviation is less than 16. So when we are filling out this, we're always going to finish with that alternate hypothesis part. So I guess our alternate hypothesis, or it's from our claim, excuse me, our alternate hypothesis is that it's less than 256. And again, here you have to square sigma, so be careful paying attention to that. Well, let's see how we did. Okay, good, 1 of 1 points. Boy, it seems like it should have been worth more than 1 point. Anyway, but there is another one worked out a little bit slower. I kind of got into trouble with the last one and the sort of a combination here. We should have our null and alternate hypothesis. We should have a picture, a shaded region, and then with the chi-square distribution, we're going to use the chi-square distribution or the chi-square distribution right tail, depending on what information we have. So anyway, I hope that's helpful for you. Good luck on section 8.1. Let me know if you have any questions.